lines and measuring line segments and the different parts of the line segment. We talked about the segment addition postulate. Today we're going to focus in the rest of this week on angles. And so before we do that, we need to talk about what a ray is. A ray is part of a line having one endpoint and extending indefinitely in one direction. I think it's like a flashlight or one of those laser pointers. I think a flashlight or a laser pointer or something like that. But it starts at a particular point and then it extends indefinitely in one direction. So this is an example of a ray. When you name a ray, you always state the endpoint first. The order really matters of the letters when you name a ray. So this would be ray MO, and you put a little mini ray on top of it, or ray MP. But you have to have the M, and it has to be the first letter, and then the second letter just has to lie on the ray somewhere. So that is how you name a ray. You can have opposite rays, like ray BA and BC. If you're told they're opposite rays, then what that tells you is that B is between A and C, which means they form a straight line, which is sometimes really important. Okay, so anytime you're told that two rays are opposite, then you can assume that they create a straight line. An angle is the intersection of two non-collinear rays at a common endpoint. So you can see here that we have ray YX and ray YZ. They intersect at point Y. They create what's called an angle. And so we want to talk first of all about how you name angles, and then we also want to talk about how you identify the sides. Let's go ahead and talk about the sides of the angle. Your sides are made up of two rays. So if I told you that intersect at a point, and that point is called the vertex, and then the two rays are the sides, how would you name those sides? What is it? Now remember, the side is a ray, so you have to name it as a ray. Ray YX and ray YZ. It's a ray. You have to start at the endpoint and go out. Right? So the sides of an angle, they're rays. You have to name them as such. If I just named X and Z, those are points. Okay, that's all that is. So you need to be specific when you name them, okay, and name them as rays. All right, now how do you name an angle? Well, there's a couple of ways that you can name an angle. If they offer you a number at the vertex, then you're going to use that number. So I can name this angle 1. That's always nice when they have that for us. You can also name it by the vertex, angle Y. But you have to be careful when you name it by the vertex. You can only do that when there are no other angles at that vertex. For example, if I had, let's see, I have these two lines that intersect, and we'll say this is X, Y, Z, W, and V. If I said angle Y, would you know which angle I was talking about? No. So in a case like this, you cannot name it just by the vertex. You have to be more specific. And so when you're more specific in naming an angle, you use a point on one of the sides, the vertex, and a point on the other side of the angle. And the vertex has to be in the middle. So we could name this angle XYZ, or you could reverse the letters and name it angle ZYX. That middle letter has to be the vertex, and then you have to have a point from one ray on one end and a point from the other ray on the other end. Okay? So different ways that you can name an angle. And notice, when I'm naming the angle, I always put the little mini angle in front of it. Parts of an angle. Okay? The parts of the angle are on the angle, in the interior of the angle, and in the exterior of the angle. When you talk about points on the angle, it's actually on the written on that angle. Q, M, and N, right? Q, M, and N. They actually lie on the physical part of the angle. Okay, so we have this angle that's like this. Anything that's inside of it, like if I were to close the angle up and sandwich it, anything that's on the inside of it, that is the interior. Okay, so that would be point S and point R. And then here's my angle again. Anything that's outside of it would be the exterior part of the angle. Okay, so what would those points be? B and O. Okay, good. So we have the angle on the angle, in the interior of the angle, and the exterior angle. Did you have a question? No? You figured it out? So here's a few questions about a different picture. And the first thing says, name all the angles that have W as the vertex. So, I come over here and I'm going to put a little dot on W. And I want all the angles that have W as the vertex. Okay, so angles 1, 2, and 3, remember you got to put a little angle symbol in front of it. Angle 1, angle 2, and angle 3. Okay, is that all? XWB is like the straight angle. You don't see anything. XWY is 1. Okay, XWY is 1. Is there any other ones? CWB. Okay, so CWB. Good. CWB. Good. And do you see how I highlight it? Makes it kind of pop out? I notice, especially with angles, when I'm naming them and I've got some lines drawn, that many times it just starts getting all mixed up. So if I highlight it, it helps. YWB. Okay. Yes, and you could name it that, but that's also angle 3. Okay, which is fine. You could name it either way, but they're the same angle. Okay. Now let's look at naming the sides of angle 1. Okay, I'm going to highlight angle 1. There is angle 1, and I want the sides of it. Now, what are the sides of the angle? They are the rays, right? So we want to name the side as a ray. So what would the two rays that make up that angle be? Ray WX and ray WZ. Good. WX and WZ. And we named them as rays, starting at the vertex and going out. Another name for angle WYZ. WYZ. Okay, angle 4. Anything else? You could go the opposite direction and say angle ZYW. Could you say angle Y? How come?
Y is just a vector.
Okay, well, Y is a point, it's the vertex. What did you say, James?
There's no other angle you see.
Well, there is another angle, though. There is one right here. See? So I couldn't use Y, because if I said Y, I wouldn't know if I was talking about this angle or that angle, right? Okay, so I wouldn't be able to just use that vertex. Okay. How about the next one? It says name a point in the interior of CWB. CWB. Name a point in the interior of that angle. Y. Good. Okay, what's a point in the exterior? Okay. What's a point on the angle? W or V or Z, right? Okay. All right. Now we're going to talk about how to measure an angle. We measure angles in degrees. We use a protractor, and I've given you some little it's a protractor compass combination. And so I'll show you how to use those here in just a minute. 1 degree is 1/360th of a turn around a circle. There's 360 degrees in a circle, right? And so it's 1/360th. If you talk about a line, you start here on a line and you go all the way over. How many degrees is that? 108. Now that's not talking about the length of the line. That's just talking about how many degrees you go from one part of the circle to the other, like on this circle part. So if I'm going to measure, sometimes before I even measure, I need to extend one of the rays so that it'll go across the number part of the protractor. Okay, so sometimes that is necessary. All right. So what you do when you measure is you take, and some protractors have a little crosshair. Yours has a gold circle. You place that crosshair or gold circle at the vertex, and then you line up the bottom ray so that it goes along the 0 and 180 mark. So the crosshair or the circle is at 0, and then you line it up along the 0 and 180 mark. Don't worry about the red and the black. Okay, we're not going to distinguish between the two. I'll explain how to determine which numbers to use. Okay, now this angle, as you can see, is less than 90 degrees, right? It's an acute angle, yes? So when we go to measure it, we start at 0, right? And we're going to work our way up. So we go 10, 20, 30, 40, 50, about 52 degrees, okay? I wouldn't use those other numbers because those numbers are decreasing, first of all, and obviously this angle is less than 90, okay? So we start here at 0, and we use those numbers that increase as our angle gets bigger. So this is about a 52-degree angle. Now, on my other one, I flipped it just so that you could see, because sometimes you use the top numbers. Okay, so again, I'm going to line this up, put that crosshair or that circle at the vertex at the angle, line this up along the 0 and 180. Now, as this angle increases, it goes 10, 20. I'm using the top numbers this time, right? And it keeps going. There's 90. It's bigger than 90. It goes, and it looks like it's about 132, 133 degrees. You're using those little compass protractors. Let me just point out a couple of things on those. So, and I just kind of disregard the red and the black. Let me get out of the... Okay, so you line up along the circle at the vertex. You make sure that bottom ray is crossing the 0, 180 mark. And again, you're going to increase 10, 20, 30, 40, 50, about 52. Has everybody used a protractor before? Anybody not ever used one before? Not much? Okay. Yeah. So that's why I'm kind of showing you all the little ins and outs here. All right. What if I asked you to create your own angle? I want you to create angle XYZ, and I want it to be 75 degrees. So you start out by drawing the bottom ray. You just draw yourself a ray. The end point of the ray is going to be the vertex of the angle, so it's going to be my Y. Now I want it to be 75 degrees. So again, I put my gold circle at the end point, and I line up my bottom ray along the 0 and 180. So then I start counting 10, 20, 30, 40, 50, 60, 75. Looks to be about right there. So I make a little dot. That tells me about where 75 degrees is. And then I move my protractor and I connect those 2 points. Between any 2 points, there's exactly one line. So I have created a 75-degree angle right there. So that's how you measure angles and create angles. Now let's talk about classifying them. And I think a lot of this you already know. You have your right angle, you have your acute angle, and you have your obtuse angle. Your right angle measures 90 degrees. This little box right here in the vertex, that red box, that tells me that that's a right angle. Okay? When you talk about what an angle measures, you need to put a little m in front of the angle. So the measure of angle A equals 90 degrees. If you don't have anything in front of the angle, it's identifying the angle. But if you're telling what it measures, you put a little m in front of it. So it says the measure of the angle. Never assume that an angle is right. Let's say you're looking at a paper or in a book, and it looks like you've got a right angle. You cannot assume. Okay, you just can never assume in geometry. If it has the little red box in there, then you can assume. Or if it tells you that the lines are perpendicular, you can assume. Or if it says that it's a right angle, then you can assume that it is. But if this is all you get, you cannot assume. Okay? All right. So a right angle measures 90 degrees. An acute angle is smaller than that. Okay? It has a range of values. And so an acute angle, angle B, is greater than 0 degrees and less than 90 degrees. Did you measure it? Is it 50? Okay, good. So it has a range of values between 0 and 90. And then your obtuse angle is your bigger angle. I think that kind of is an obtuse angle. It has a range of values also, and it is greater than 0 and greater than 90 and less than 180. So it's bigger than a right angle and smaller than a straight line. Okay, so it's between 90 and 180. I think you guys know this is like probably 4th grade, 5th grade. Congruent angles. We talked about congruent segments last week. Congruent angles are angles that have the same measure. Now, see how they have a little m in front of it? They're talking about the measure of it. So the measure of NMP and the measure of QMR are equal. And notice they're both labeled by 25 degrees. If you know that two angles have the same measure, you can say that they're congruent. When we mark angles congruent, we use little arcs. Okay? And if you look at a diagram and they have these little arcs like that, that is an indication that those two angles are the same. And so, if they have the same measure, you can say that they're congruent, and vice versa. If you say they're congruent, then you know that they have the same measure. You can have more than one congruent pair of angles. Okay? So, like, let's say these two angles are congruent, and these two. Just like with the line segments, you can use a single arc and a double arc. And that would say that the single arc ones are the same, and the double arc ones are the same. Angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. We talked about segment bisectors last week, right? What does a segment bisector do? What does it do to a segment? But what does that mean? It divides it into two congruent parts, right? Because it goes through the midpoint, yes? Well, we don't really have a midpoint on an angle, but it's that same idea. It is a ray that goes right smack dab through the middle of the angle and creates two congruent angles. So this right here is an angle bisector, because it goes through the bigger angle and breaks it into two congruent smaller angles. That is an angle bisector. Alright, so let's answer a couple of questions here. I'm going to do this problem, and then I'm going to change it up a little bit and show you a couple other scenarios that you can see. Alright, in the figure, QP and QR are opposite rays. What does that tell me? They make a straight line, right? Okay, they make a straight line. That's important. It says that ray QT bisects angle RQS. What can I get from that? QT bisects RQS.
That's exactly how
It's exactly half of the bigger one. It breaks that big angle into two smaller parts, because this is the angle, this is the bisector, so it breaks these into two equal parts, yes? Okay, that's important too. If the measure of RQT is 6x plus 5, RQT is 6x plus 5, and SQT is 7x minus 2, find the measure of angle RQT. So I want to find the measure of this angle RQT. In order to do that, I have to find x, and in order to find x, I have to set up an equation. And in order to set up an equation, I need two things that are equal. Do I have anything that's equal? These two angles are equal to each other, correct? So I can set them equal to each other. So 7x minus 2 equals 6x plus 5. So I'm going to solve for x, move the x over, and add 2 to both sides. So x is 7. Are we done? No, and a lot of you made a mistake on the test. You found x, but you didn't go back and find what it was that it asked. So be careful. Okay, we need the measure of RQT. Okay, so we go in and we substitute 6 times 7 plus 5, which is 42 plus 5, which is 47 degrees. Okay, that's one scenario. Okay, no problem. Let's say, and I'm not going to work these out, I want you to help, just know how to set them up. This is 7x minus 2, right? Let's say I told you that this big angle here was 78, and I want you to find x. And we still know that QT bisects, right? What would you do? Yes. Over 2. You're thinking right, but you're backwards. Times 2, right? If this whole thing is 78, and these two are equal, this is going to be 7x minus 2, and that's going to be 7x minus 2, right? So you would do 2 times 7x minus 2 equals 78. You're on the right track, you just work through backwards, okay? Another thing you could do is, since we know that this right here is 78 and this bisects, what does it make this angle measure? This whole thing is 78, this is the bisector, 39, right? And so then you can set 7x minus 2 equal to 39. Alright, that's another thing you can do. Okay, last little thing here. Let's say this was back to 6x plus 5. And let's say this is 3x plus 9. Okay? Now, I don't necessarily know that QT is an angle bisector anymore. Okay? What would I have to do in this situation to find x? Hand up. I heard it. Remember, a straight line goes from 0 all the way over to 180, like a semicircle, right? So since this is a straight line, wouldn't this angle plus this angle plus this angle equal 180, right? So it's kind of like the segment addition postulate, but it's the angle addition postulate. This angle plus that angle equals the whole angle, right? Okay, so that would be what you would do. 6x plus 5 plus 7x minus 2 plus 3x plus 9 equals 180. Any questions? All right. That's a worksheet.